Welcome back. In our previous discussion, we explored vibe coding and its impact on development workflows. Today, we're diving deeper into building PydanticAI agents with Roo Code, an AI-powered coding agent that integrates seamlessly into Visual Studio Code. For today's agent, we're building a math tutor agent for primary school students where we can ask questions and the agent will provide us answers along with an explanation and steps how to solve the problem. It's really cool, and what we're going to do is we're going to build this entirely in Roo Code with one prompt, and hopefully it will work the first time. Now, Roo Code is an intelligent coding assistant capable of taking prompts in natural language, acting as an agent, so it does have an agent mode, creating multiple files simultaneously, as well as break down large tasks into smaller pieces. It can read and write files directly inside your workspace. It can run terminal commands. It can automate browser actions. It can work with OpenAI compatible or custom models. It can adapt its personality and capabilities through the custom modes. And finally, it can also integrate with MCP servers. It's a topic we haven't touched on yet, but very important for vibe coding tools such as Cursor, Roo Code, Visual Studio Code, Copilot. These tools, when integrated with MCP servers, basically they can add a capability that is not built into the tool. Imagine an MCP server that does database operations, or MCP server that just acts as an external tool to one of the agents. Those are capabilities that you can basically plug and play into the vibe coding tool and extend its functionality. Super cool. Now, in this tutorial, we'll demonstrate how to harness Roo Code and how to work with it effectively, and we'll look for best practices how to avoid common pitfalls such as generating garbage or introducing technical debt such as bloated methods or code duplication. Again, this is one of the issues with a lot of these tools, is that when they start generating multiple files, they will generate a method in one file and then generate similar methods in other files, leading to code duplication. Now you can have a second pass and a third pass and inspect the code base and refactor these code dupe methods, but why don't we get it right the first time? So we'll look at some of the tools, some of the tips and tricks how to get it right the first time. By providing Roo Code with precise instructions, relevant context, and clear constraints, you can enhance the quality of the generated code significantly, save yourself time, and most importantly, save a lot of frustration. Especially if you're a beginner in vibe coding, if the first couple of weeks can be particularly treacherous when you are learning some of the weaknesses and some of the ways in which you can make the use of this tool more effective. Now let's talk about setup and running Roo Code inside Visual Studio Code. As I mentioned, Roo Code is an open source project hosted on GitHub, and here you can access the tool at github.com/roovetgit/roocode. This is the address. I will include the link in the video description. You can go ahead and read some of the features on their GitHub repo. It is a clone of the Klein tool, so it does have significant overlap in features with Klein, but this is a new version of Klein. And they have guides for installing Roo Code, so the documentation website I found to be supremely helpful. These step-by-step instructions are very helpful. In this case, connecting to a provider. It's very important to understand that Roo Code in and of itself is not an LLM. It's not a model. You do have to connect it with a LLM, and you have to have your own keys. And the best models that I found useful for code generation are usually the Anthropic models, Claude 3.5, 3.7, the reasoning models, as well as some of the OpenAI more expensive models. But lately, Gemini 2.5 Pro is also doing an amazing job in code generation. So this section of the documentation walks you through how to connect your keys and how to enter your keys and how to configure Roo Code so that it's ready for your execution. Your first task is so important. It's such a nice article to get you onboarded into the tool. I highly recommend you check it out and see. It's a very simple way to get started with Roo Code once you have your keys ready and once you have your model connected to the tool. Once you get off the website and once you install it into Visual Studio Code, and by the way, the installation is you click on the extensions, you search for Roo Code, and the tool that comes with 300 or 400,000 installations is likely the right tool. Hit install and it will install itself into your Visual Studio workspace. Once installed, you can access this from the left toolbar menu, and in some cases, if you're not seeing the icon, just click on the three dots and it's one of the icons. So I have many extensions in Visual Studio Code, and for that reason it won't be able to display all of them, but by clicking the three dots you'll access all of your Visual Studio Code extensions. As you can see, Roo Code for me is the last item on the list, so I'm going to go ahead and click that. And that will open the Roo Code main chat interface. That's the box on the left-hand side. The one on the bottom is the actual chat interface. And at the very bottom, you have the action buttons. On the left, you see the code, and that's the mode it operates in. It has the architect mode, the code mode, and some of these are agentic flows as well. Then the default specifies which model you use. And then on the right-hand side, you have the AI, which is a prompt generator. You have the ability to upload a picture, and through the picture, you can actually ask Roo Code to generate code based on a mockup, for example. And then the last one is the submit button. So let's go ahead and explore this. These are some of the tasks that I've ran earlier. And so if you click the code, you will see that the code is the default mode selected, but there's also the architect and ask and debug. I love the architect mode when I start a brand new project. If you're unsure how to break up a large task into smaller pieces, start in the architect mode. Give it a large question or a generic question such as, I'd like to create a full stack app for signing up users for a weekend event. That's a very large prompt, and it could go in many different directions, but the architect mode breaks it down into chunks and then asks for your approval in each one of these steps. So you have a chance to review these and approve them or modify them as they fit your needs. You can change the stack, you can change the logic, you can add more or fewer items on that list. So architect mode is great to start, and once you have the system designed and architected, then you can switch to coding mode, and then it kicks in the agent mode and starts generating coding assets. All right, and if things don't go well, then you can switch to debug mode, and it actually is very helpful to troubleshoot and understand issues with the system. Once the coding assets are generated, I would say in the majority of the cases, it will not work the first time. Don't expect it to come up with a fully functional 100% working solution the very first prompt. It will take a few iterations and fixing. So the debug mode there is actually very helpful for those debugging sessions. And next to that is the default, and you can click the edit button, and once you do that, you go into the model configuration area. In this case, I have configured the tool to use Gemini, and I'm using the Gemini 2.5 Pro model, which just came out about a week ago, which is an amazing new model for code generation. I highly recommend and you test it. If you don't have Gemini paid plans, one of the ways you can get that is by creating a new Google account and receiving the $300 credit, which every new Google Cloud user gets, and use that $300 credit by associating your Google Cloud account with your Google AI Studio account, and from there grab the Gemini key and pass it here. So that's one way for you to give it a test drive. $300 US is a good amount of budget to experiment and understand the strengths of the Gemini 2.5 Pro model, because it's very capable, and Roo Code is very frugal with its prompts, and so you can get quite a bit of mileage, create a few apps, and get a true sense of whether Roo Code and Gemini 2.5 are the right models for you long term. All right, if you click on the settings, then you will see that you have a number of settings, including providers, auto approve, checkpoints, notifications, Context management is super cool because you will probably keep adding more context to the database so you can manage the sources. Specifically for PydanticAI, for example, a lot of the models, including the Gemini 2.5, are still unaware of the PydanticAI documentation and API. So you will likely be providing them into the context, and they will be added into the context database. So you will be providing them as files, more likely PDF files, JSON files, HTML files, which will then be added into its local RAG system. Then there's the terminal, there's advanced features, experimental features, language, and about. So it's a very nicely designed chat system for you to get started with vibe coding. Once you explore these options in the menu, then you are pretty much done with this section of Roo Code. You can explore the different models. I have settled on Google Gemini, but there are many other models that are supported, including the AWS Bedrock models, DeepSeek models, LM Studio. If you have a local LM Studio and you'd like to use one of your local Ollama models, for instance, if you don't want to pay for a model provider, you can also use a local model through the LM Studio integration. Okay, you can also use Mistral models as well as directly using Ollama models by providing your Ollama server. You can be running an Ollama model locally on your laptop, or you could have a machine on your network with the GPU running Ollama, and then you can provide its IP address so that the Roo Code uses the Ollama model, whether it's 70 billion or 400 billion parameter model. They do quite a good of a job when it comes to code generation as well, but it has to be a powerful model. My experience with the smaller models, 7 billion, 13 billion parameter models, hasn't been great. So once this is done, you can type your question in the type your task here. That input box is where you will end up pasting your prompt. So let's go ahead and grab a sample prompt. In this case, my prompt is create a Python file for a PydanticAI agent to act as a math tutor. So we're going to be covering this example today, creating a math tutor PydanticAI agent using the Roo Code tool. So I've prepared this prompt prior to this session, and I've used this prompt with other tools as well, including Cursor, Windsurf, and GitHub Copilot. So this is my standard prompt that I use for testing various vibe coding tools. Although the models may change or the setup may change, this prompt largely stays the same because it works. It's a prescriptive, it's a highly descriptive prompt, and when I pass this to Roo Code, I hope that it will understand and be able to parse it and understand what I'm trying to accomplish. So I've prepared this. It will be provided into video. So if you need a prompt like this, you can just grab this from the AI Software Developers School resources. So get it from the resources. This prompt, along with other reusable prompts, will be part of the AI Software Developers library. So it's available to all members. The important thing here is that it should be a detailed prompt. It should be very descriptive of your intent and giving clear guidelines as well as guardrails to the tool so that it understands the intent and knows which libraries and APIs to use, and more importantly, perhaps which ones to avoid. So we're going to grab this. We're going to copy the entire prompt. For this prompt, I'm generating a math tutor agent, and the response will be a math response class. This will be a Pydantic class. I'm not specifying the fields inside the response type. I'll let the LLM figure that out. Just specifying that I want to create a total of 4 math operations as tools. So it's going to be 4 tools, and I'm providing guidelines such as @agent.tool_plain decorator, because I don't expect these tools to use the context. You may or may not specify this. I just find it to be more effective if I add as much information as I can upfront so that the tool doesn't veer off in various different directions. All right, so let's continue. And this is the entire prompt. It's highly reusable for other agent types, by the way. I have reused this just by changing the math tutor to health agent, for example, and change the response type to health agent response and the various parts to fit that new agent type. So you can, over time, develop a reusable library of prompts as well, as context files for these vibe coding tools. Let's go ahead and grab this, copy this entire prompt. And now we're going to go back to Roo Code, and inside the Roo Code interface is where the context is. So I'd like to show you how to add context to Roo Code. In this case, there are a number of JSON files. One of our members has already scraped the PydanticAI website and created a set of JSON files. So this is a reusable source for our members. These JSON files basically include the content of the website. This is very important because certain tools like Roo Code are unable to grab a web document context, but they're able to get this from the workspace, as I'll show you in a couple minutes. So if your tool is not able to access or scrape a web resource as a context, then your options are either download it as a PDF file or download it as HTML, or just scrape the entire website in a series of JSON files. These all should work if they're added to the local workspace and added to the tool as extra context. So these JSON files are just a PydanticAI website with the various APIs and classes and definitions. All right, so we can scroll and see different content items. These are all going to get parsed and put in a RAG system locally inside Roo Code and Visual Studio Code. So that's one set of context files. The second context is the rules. In this case, I've included 5: Poetry, PydanticAI, Pydantic for the plain Pydantic classes, PyTest, and Python. I figured that for this project, these rule files should be enough and sufficient, and they're part of the context library as well. I'll show you ways how to generate your own MDC files that you can use both in Roo Code, but also with Cursor and GitHub Copilot. Now, if we actually take a look at the PydanticAI MDC files, we'll see that we have quite a bit of logic here. It's a rather long file, and it specifies how to use PydanticAI and the rules around creating PydanticAI agents. The tools usage, the context usage, so on and so forth. We're back into the Roo Code interface, and here's how you add the context. When you type add, it prompts this menu going up, and from this menu, you go ahead and the options are you can add problems, you can add terminal, you can add paste URL to fetch contents, but this is iffy, by the way. But you can try and see if it works, because it didn't work for me in a couple of occasions. It only parsed the first page, and it wasn't able to get the entire 3 when I provided this. So you will have to paste a lot of pages if you want the entire website to be added, whereas other tools are able to grab it as a root and just kind of scrape the entire root of that website. Experiment with paste URL to fetch contents, but also understand that it could be just one page per URL. So if you want the entire website, you'll have to provide something like 150 links. And instead, what I'm going to do is add folder. So I will do add folder. Click that, and as soon as I add folder, it lists all the folders in my workspace. So context, AI PydanticAI.dev, or context.rules, or I can just include the context folder, which I will do. So I include the context folder, the entire folder, which includes the rules and the PydanticAI website, and then I paste my long prompt. Create a new Python file for an agent, and everything that you saw earlier in my TextMate editor, I just brought over that text and pasted it inside my Roo Code prompt box. With that, I have added the context, I have added a good prompt, we're ready to launch the tool. So once you hit the submit button, it will go ahead and create that one file, which is basically going to be named the math_tutor_agent.py. I've done this already, so I'm not going to run it again, but basically it will create this file. With that prompt and Gemini 2.5, you're going to get more or less a file that looks like this. Let's take a look at this. The math response class here is the first one. It has greetings, explanation, step-by-step instructions, examples, practice problems, and tips. This is a pretty good response type. I did not specify the fields, but it was able to come up with its own explanation and step-by-step. A lot of them are lists. I am happy actually to see that the examples are optional, and it's a list of strings, so we get a couple of examples. Then we have our model, also very good because I provided so much detail in the prompt. The agent creation itself is accurate, and it does agent and then passing the model, and then the result type is math response. That's also pretty cool. And now we are looking at 4 tools: add, subtract, multiply, and divide. Each operation is defined as a tool, so that's also really good. So just inspecting and eyeballing the code. And finally, we're looking at agent.system prompt. This is perhaps one of the most important aspects, and I'm looking at a great system prompt here. You're a friendly, helpful math tutor. When the student asks a question, follow these steps. Always respond with the math response model. This provides a very good instruction for the agent of what to do. Then we're looking at an asynchronous main method, which is going to run as a loop, and it will basically ask questions and on the terminal, and users can ask math questions. This looks like a very typical agent script that I would write for one of my tutorials if I had done this manually. The difference being is that I would spend a half an hour or an hour or maybe 2 thinking and coming up with these classes and debugging, and with something like Roo Code, this literally took less than a minute. Given that I have a working prompt, of course you do end up spending time with the prompt and debugging, and it doesn't work 100% the first time, but still the time savings are considerable. We have a main method and we have async IO. Let's go ahead and run this quick agent, and we'll see a little bit of math back and forth. My first question will be, what is 4 plus 7? Very simple question. Let's assume this is primary school agent. We see that the answer came back in the structured response type, which was math response. And we see that we have step-by-step instructions, examples, more practice problems, and we have a helpful tip compliant with the result type. Now, let's go ahead and ask something a little more complicated. And the question will be, what is the area of a circle with a radius of 18 meters? And now it's going to put a little bit more thinking. Obviously, this is not a primary school question, or at least not for K through 3. Let's go ahead and think of what are the answers here. Hi there, let's find the area. This area of a circle is found using the formula. Area is pi times r square, where r is the radius. So this is really nice explanation. Then we get the steps, and then we find the final solution at number 5 is 322 square meters. So there are a couple of examples and there are a couple of practice problems. So really compliant way to display the results. So Roo Code generated this code and it did work in the first shot. Let's move on. This is the prompt in its entirety. I included this as a slide, so perhaps you can get inspired or you can grab this and create your own prompt. But this is the level of rigor that I found to be useful for creating PydanticAI agents that actually work. Otherwise, there are parts that are missed. The LLMs are not familiar with the PydanticAI APIs or signatures, and they keep inventing new methods and new class. Honestly, at some point it becomes so much garbage that actually fixing it's more effort. So what I ended up doing in my workflow is just keep improving the prompt and reprompting, and just discarding the old solution. That may be a good way to create good reusable prompts if you're dealing with single purpose agents. Once you get to a more complicated app, like a full stack app or multiple agent orchestrated by something else, then things may get even more complicated. That's why it's so important to get these single purpose agents right with solid prompts, because you can then start building your own prompt library based on solid foundations. Let's move on. Just quickly to summarize this, great prompts are descriptive, they're prescriptive, and they're restrictive. I've included this slide in a couple other videos, but I'm repeating this because it's so important. A descriptive prompt is very helpful to the LLM to generate the right code, because it provides a great level of detail necessary to create these artifacts, especially for esoteric frameworks or brand new frameworks where the LLM has not been trained on. Providing this inside the prompt or the rules files is essential for great code generation. Prescriptive means that it's broken down to steps that are smaller and that the LLM can take and execute individually, and also provide inputs along the way. Sometimes when you have a large prompt, some of these models, Roo Code included, would take a pause and ask for further input. They would execute a step or two, pause and say, does everything look okay? Do you want to make any changes? And that gives you an ability to inject your input inside the creation process. So it's not just one shot thing, and that's why it's important to break down a prompt into smaller steps. And finally, restrictive, because you need to put guardrails, otherwise the models go into all sorts of directions and add classes or libraries or APIs that A, you may not need, B, you don't want, or C, they end up creating code duplication that will become technical debt at some other point. So great prompts have these features. Study the art of prompt engineering, and it will be a very helpful investment in your AI development career. I also want to share a little bit of a discussion that we've had with a few members in the school related to the example that I already covered, but adds a little bit more detail that you may find interesting. This is done in real time, and so hopefully the audio will work just as well as this audio. But what you can glean from this is some of the details that go into the process of good, solid vibe coding and what are some of the gotchas. So this is a short discussion that I hope you'll find helpful. I want to show you the last tool, which is the Roo Code. So it's an extension to Visual Studio Code. You download it and then you set up your own keys. I've set up my own keys and I've set it up for Gemini 2.5 Pro. You can configure it from here. You can just go and say edit, and here from Google Gemini, you can pick the model. So as you can see, in my case, is Gemini 2.5 Pro, the new one that just came out a couple of days ago, 0325 basically. With Roo Code, I want to emphasize is that the really awesome feature is that you can tap add, and then you can add file, folder, or whatever. But when you go to add folder, it's context. It's very much like Visual Studio Code. It does not yet support any URL, but as long as you have your context file in the workspace, you can add them as context to Roo Code, and it does make a difference. Let's start with this first example. I'll try to make this a little larger. And for this, let's go with a simple math tutor for primary school students. That's the agent we want to create with PydanticAI. We'll just pick one random tool, doesn't matter. I did this earlier today. I started with a simple prompt like this, but over time with trial and error, this prompt went to this length. I think there is a point where you kind of come to a conclusion where this is detailed enough. I'm just going to push this, let the agent do its job, and then I'll fix it, because you will never get to 100% accurate code, even with all the context. I mean, at the current stage of models and tools, in 6 months, a year, 2 years, different story. But right now, it's the vibe coding produces 80% complete code, and you still have to go and fix classes. It hallucinates even when you provide all the APIs. It creates classes out of nowhere. The APIs are messed up. The imports are messed up, and you have to go and intervene manually. If you're creating in PydanticAI, you need a basic understanding of the class structure, that you need an agent. You need a model to be passed to the agent. If you're doing LangGraph, you need a basic understanding of LangGraph. It is not yet, the PydanticAI is just too new, and LangGraph is just too new for these models to be 100% accurate with this. Now, it's not the same with Next.js and React and, let's say, .NET or C# projects. Those can be 100% accurate, because if you go to GitHub, where these models were trained with, I would say 40-50% of GitHub is probably Next.js and React anyway. But very tiny percent is PydanticAI. These models basically know nothing about PydanticAI because it was released 3 months ago. So think about it that way. We're using these fancy models, but they have no knowledge of PydanticAI. Even this, what they're coming up, is amazing quality. But keep that in mind, that the more esoteric the framework you use, the more cutting edge version-wise you're with a particular framework, the less effective the produced agent code will become. I use the 3 things: be descriptive, prescriptive, and restrictive in these prompts. Describe as much as you can. Prescribe, which is step by step. This defines a direction and temporal step by step. And restrictive, also tell the agent what not to do.
So the main takeaway for me is that by and large, most of this will port over to other projects. I see only the first line is where you're describing the real outcome of the code.
Exactly. Actually, the logic, I don't have to describe it a lot. So this is completely reusable if you're going to build more agents. In fact, if you look at my other example, I just changed this, but I just replaced the first line with a weather chatbot instead of a math tutor. I'm using a weather chatbot, and instead of calculation tools, I just ask it to create a tool that gets the real weather through an API. So you can just replace relevant lines and by and large keep this as your golden agent creation source. So let's grab this. I will just copy this. Before we start, I want to show you this agent that I created so you have an idea of what it does. So we're going to do Python and math tutor agent. Math tutor AI, ask primary school math question. What is 1 + 1? So this is using GPT-4o mini model. Should be fast. Does its step-by-step solution. It does more examples, and it does try these practice problems. All of this was, guys, generated by Roo Code, but this system prompt is amazing. I didn't write any system prompts, but beyond the system prompt, I think this math response class is amazing also. There's a greeting, there's explanation, there's step-by-step instructions, there's examples, practice problems, and tips. So pretty cool Pydantic response model class.
Prompt was also generated. So you only wrote the big prompt you showed us.
Exactly. I only wrote the big prompt. The tool wrote both the response, but in the big prompt, if you look at this, I am asking it to create a system prompt descriptive with steps, but I'm not saying what to write in it. Create a system prompt using @agent.systemPromptDecorator. I have to tell it to do this, otherwise it doesn't know how to do it.
So cool. I can never write more than 2 lines of system prompt.
I say ensure the system prompt includes step-by-step instructions on how to run the agent and use the tool as well as structure of the result type. This is really important so that you tie it to the result type. Just invoke and how it should be asynchronous and should await for the .run to finish. Otherwise, again, it doesn't know how to run these agents. So it does create the base response model, which is we want Pydantic to respond with a typed response. This is how we create the model. Here's our agent. And here are our 4 tools. So 1 tool for each operation. Pretty cool. This is the system prompt. Amazing system prompt. It says, remember to be encouraging and positive.
Yeah, I like that.
Appropriate for primary school students, right? It just picked up from my prompt that this is a tool for primary school students. Let's look at the results, and it says, hello there. When we add 1 and 1 together, we're combining 2 units to find out how many we have in total. The total is 2. I mean, this is a super simple language. Now let's ask something a little more complicated. What is the area of a cube with a length of 8 meters? It should still be able to calculate it, but I want to see these steps. Hey there, let's explore the area of a cube together. Okay, cool. A cube has 6 faces, and the area is typically calculated. The cube refers to its surface area. Step-by-step instructions. Good. Calculate surface area 6 times 64. Some more examples. So not bad.
Yeah, this is very good.
Okay, so now that we've seen how Roo Code works, I'd like to share with you one useful tool from GitHub that can help you generate MDC rules files that you can use for Roo Code and other vibe coding tools. It's called MDC Rules Generator, and it can be found in the Sanjeet 5/awesome cursor rules MDC. The link will be in the video description, but I'd like to run a quick demo here to show you how this tool works. You can get the tool from github.com Sanjeet 5/awesome cursor rules MDC, and once in the GitHub repo, you can actually browse and see the available rules. So you will see that there's already couple hundred rules included with this repo. So your stack might already be included, so you will not have to regenerate it. But in case it's not there, it's very simple to add your tool or your framework like we're going to do with PydanticAI and use the tool to automatically generate this. The tool uses an LLM, so it's AI-based rules generator. It will generate a baseline rule files, which is a good starting point for you to customize. What we're looking at right now is the pydantic.mdc .mdc. This is the straight Pydantic rule file. It's not the PydanticAI. They do not include the PydanticAI in this repo. You can take a look at how the model definition guardrails are or other specifics how to generate Pydantic models. Grab the URL and open a terminal, or in Visual Studio open the integrated terminal and just do git clone. So I'm just going to type git space clone and paste the repo URL here. And once you hit enter, this will bring all the files from the remote GitHub repo to your local machine. Once the files are checked out, just go to that folder and open Visual Studio Code. So here's a quick inspection of what was brought in. And by the way, it will only bring .env.example. That .env is something I created later on. You will have to create your own .env file, including your OpenAI keys. So let's launch Visual Studio Code from this folder and then inspect what's inside the project. Once inside Visual Studio Code, the main file here is the rules.json. I'm going to go ahead and close this file right now, just so we have an idea of the folder structure. One thing you'll see is the cursor rules CLI, then the rules-mdc is where rules are hosted, and then rules v0 deprecated, and then the source. The most important file will be the rules.json at the bottom on the left, and the rules-mdc, which will be the folder which will include all the MDC files. Now the process is you will edit the rules.json file, add your own rules that you want generated, then run the generator. Then once the rules are generated, copy these MDC files into the workspace where you use cursor or Roo Code, and then add them to the context as I showed in the earlier section. All right, so let's go ahead and do that. We're going to open rules.json now, and we'll look for Pydantic or PydanticAI. Let's go ahead and find the Pydantic section here. We're going to search for Pydantic, and sure enough, there's Pydantic, but there's also a PydanticAI, which I added. Now, this is the standard Pydantic class. You'll just need to copy this and rename that to PydanticAI. That's exactly what I did, and you can change the tags. I included 5 tags, but feel free to add your own tags if that will make a difference. AI, agent, LLM, Python, and framework is the ones that I included. So here we have a PydanticAI entry into this JSON file. So save the JSON file. Once this is done, then we're ready to run the generator. But first, make sure that everything checks out and the JSON file is formatted properly. Open the integrated terminal and run it with uv run src generate mdc files.py. Let's go ahead and kick off the script. Once the script finishes, hopefully successfully, if you have your keys and if you have the JSON file formatted properly, it should work. And now we can go back to the rules mdc folder and inspect and look for our PydanticAI.mdc file. So scroll down to the P section and let's open our file. Find it and open it first. There you go. So we have a new file, and as you can see, it's green, means it's not checked into the repo yet. Let's go ahead and inspect this file. And one thing we'll notice here is that it's a rather comprehensive and long file with a couple hundred lines of rules. We have a nice project root structure with agents, models, tools, prompts, dependencies. This may or may not work for you. I just left it as is. There is a room for improvement in this project structure, but the same thing that is handicapping a regular model that they don't know about PydanticAI is also a restriction here when we generate these files. The OpenAI model that generated this MDC file is not really aware of PydanticAI, and that's why it displays a bit of a generic folder structure, but I was okay with that. It's not a big problem. If you look at the component architecture, you have agents, models, tools, and dependencies, which is okay-ish, but this is where you can add your own rules and your own guardrails for the tool to follow. Section 1.4 is where you would actually customize it and add a lot more rigor. So the prompt that I showed you before, there's a lot of sections from that prompt that can become reusable assets in a rules file like this. If you're using them over and over, I would then start moving them from the prompt into these rule files. files, you'll end up with one reusable MDC rule file for PydanticAI that will apply to multiple agents. Let me give you an example. Line 83 is the agent must use the OS and .env packages and use the OpenAI API key. Line 85, create the model instance first and then pass the model and the API key. I'm giving it an example how to do that. So that's one of the other ways to enhance these MDC files is by providing coding examples or specific libraries to be used or package names, which I'm also doing later on. Then on line 88, create an instance of the agent using the PydanticAI agent class. And here's the example: agent equal to agent, model equal to model, result type is the result type Pydantic model. The tool will figure it out how to structure it with its own response type. Line 91, if the tool doesn't need access to the runtime context, create a plain tool, otherwise create a tool, and make sure to pass the runtime context as the first parameter, otherwise it will not compile. So you will include as much detail as you need to, but this step is so important to get it right, because without these examples and without these guardrails, the code generated will be hallucinated, will be duplicative, and in many cases will be either incomplete or complete garbage. You will have to start from scratch. Take this as a template. It will be available to school students, and there is plenty of templates like this online for various frameworks as well. Good. Let's move on. Let's summarize. I hope that the demos today have given an idea of what Roo Code can do for you. By making Roo Code part of your development workflow, you're not just adding a new tool, you're actually gaining an intelligent coworker that understands your goals and helps you achieve them faster. But there are some pitfalls to avoid. We've worked on a couple of examples where we provided clear instructions in the form of MDC files that are rules or tasks, but also extra context files such as the entire PydanticAI website in the form of JSON files. Roo Code is an amazing tool. Let me just be clear with you. It's on par as far as quality and the agentic workflow with more expensive tools such as Cursor and Visual Studio Copilot. PydanticAI is a challenging framework for models like Gemini as well as the Claude models because they're not trained on the PydanticAI data just yet. But you can supplement the context to the tool with the methods and the techniques that I've already covered. You can start with a solid set of rules.mdc files, then move on to writing great prompts, and then iteration and experimentation will be key to success. Roo Code is one of these tools that is free to use. It makes it one of the least expensive in this category because the only thing you need to pay is model costs. So if you're paying for Gemini Access or for Claude 3.5, if you already have a key or your employer is providing you a key, Roo Code is there entirely free as long as you integrate it with an existing key. So that makes it a great choice. I hope that this short tutorial gave you an idea, perhaps even inspired you to try Roo Code. Let me know how it goes. For today, this is a wrap, and I'd like to thank you for sticking around. In this video, we've demonstrated that a structured approach to vibe coding with a tool such as Roo Code will give you a significant boost when implementing agent-based systems. If you find this tutorial helpful, hit that like button, subscribe, and let me know in the comments, what are you building with Roo Code? Until next time, keep building amazing agents.